Which of the following methods can be used to separate components of a blood sample? So remember, blood has a lot of things in it that are both dissolved, not dissolved, just floating around through it. So in your blood, you'd have blood cells, you'd have platelets, what else would you have? White blood cells, proteins. So all of these things would be floating around your blood, and they wouldn't necessarily be dissolved. So you wouldn't need to separate using fractional distillation or anything, because it might damage your blood. Okay, so separating funnel and sieving are probably not your best options, because remember, okay, sieving firstly is for sort of big particles, and all of the components of your blood are microscopic, so probably not B. Separating funnel is for two things that are not miscible in one another, so for instance, water and oil, whereas the blood has lots of things sort of suspended in it. So the separating funnel doesn't really work for blood. So that leaves these two, centrifugation and chromatography. So we could centrifuge the thing, spin it around, and then the densest particles will fall to the bottom, and the least dense particles will sit on top. And there's this thing called chromatography. You probably haven't studied chromatography, so it's probably not the best one to pick. So centrifugation is probably the correct answer. And there you go. So chromatography can be used, but it's probably not the best. It's probably the slowest method to use because it's very, very, very selective with what it lets through the filter, essentially. So what is the principle behind the separating funnel technique? So you need to have, there's a reason why we use the separating funnel, and it's based on a particular principle. So because we're not boiling anything, it's probably not A, because in a separating funnel you don't heat it, so it's not going to be A. Okay, particle size difference and immiscibility. So you don't really see you don't see any suspended substances put through a separating funnel unless they just want to put the suspended substance in the separating funnel for no apparent reason. So particle size difference doesn't really play a part in the separating funnel method, so it's not B. Okay. So solubility difference and immiscibility. Okay. Again, this one is sort of it sounds kind of correct because you're talking about insolubility and things like that, but solubility is about dissolving solids generally. So we don't really see solids being dissolved in a separating funnel either. So it's not C. What we are looking for is a density difference and immiscibility, because you want one liquid to sit on the bottom and one liquid to sit on top because of the difference in densities. And then you want them to be not miscible so that you can just pour out the bottom liquid and stop when you get the top liquid down to basically the nozzle. So you want to close the valve when all of the bottom liquid has run out, and then you've just got the top liquid sitting inside your separating funnel. So D, you want it to be different in density, and also you want them to be immiscible. And that's when you know you can use the separating funnel. When the two liquids are different densities and won't dissolve in one another. And that's when you use the separating funnel. Okay. Which of the following elements would naturally be found as a compound? Okay, naturally found as a compound. So you've got platinum. So platinum is one of the rare earth type metals. It is also one of the metals that we can find in natural form. So you can find platinum completely unbound, and that's why it's sort of nice. We sort of revere, or not revere as much as we value platinum very highly because of that. So we're not likely to find that as a compound. Helium. Helium is a noble gas. It doesn't want to bond with anything, so we're not likely to find any helium compounds. And gold, again, like platinum, is a sort of noble metal. It doesn't really want to bond with anything. It's unreactive. So it's not likely we'll find this as a compound. But oxygen we know we find as thousands of compounds. So A is probably the correct answer. Okay.